In the previous video lecture, we were able to derive the mathematical expression for the dependence of Gibbs free energy on temperature. So, yung form ng equation na yon is yung change in Gibbs free energy, or actually it's the ratio of G over T with respect to temperature at constant pressure, equal lang siya sa minus h over t squared. So yan yung tinutukoy natin na temperature dependence of change in delta G or change in G. Now, we're going to transform this equation in a form na mas madaling i-calculate yung delta G. So, ang gagawin ko is I just need to separate the variables, right? So, magiging differential of G over T. Okay, so d G over T, okay, equals minus h over T squared dt. So, ang gagawin dito is we will simply integrate from initial to final, from initial to final. And if you do the integration, ang lalabas is you will be able to get delta G2 at a certain temperature T2 minus delta G1 at a certain temperature T1 equals delta H times 1 over T2 minus 1 over T1. Kapag isang reaction ang tinutukoy natin, whether it's a chemical reaction or a reaction that's happening in a cell, we can modify this equation a little bit, wherein yung delta G1, gagawin natin siyang reference Gibbs free energy. And normally, we use a reference temperature of 298 Kelvin. So, for us to determine the reaction free energy at a certain temperature T, okay, so yan yung magiging expression natin, that will be equal to the reaction free energy at 298 Kelvin. Okay, so divided by 298, I'm just following the previous formula. Okay, plus the enthalpy, and in this case that will be the enthalpy of reaction. Okay, standard state 1 over temperature, which is unknown, minus 1 over 298. This equation now, and the previous equation also, ang tawag dyan ay Gibbs-Helmholtz Equation. And this equation is very useful kasi nga malalaman natin ang delta G at different temperature. So for example, let's have the following reaction. So we have albumin, which is the protein found in egg. Okay, now it's found in liquid state, for example. Tapos yung transformation na gagawin natin is albumin in the solid state. And this is what happens when you cook your egg, no? Yung albumin in the liquid state will be converted to albumin in the solid state. Now, it is known na ang enthalpy of reaction for this transformation, okay, at 298 Kelvin is equal to 35 kilojoules per mole. And the reaction free energy at the same temperature is 5.7 kilojoules per mole. Now, here are my questions. Number 1, will albumin harden at 100 degrees Celsius? So, kung 100 degrees Celsius yung temperature kung saan nagbo-boil kayo ng water, kung saan nyo ilalagay yung egg, at that temperature, titigas ba ang albumin sa egg? And my second question is, at what temperature will albumin start to solidify? So let's focus first on the first question. Okay? So, ang gagawin natin is we just have to apply the Gibbs-Helmholtz equation. Okay? So, ang Gibbs-Helmholtz equation is we want to find the Gibbs free energy at 373 Kelvin, right? Or yung 100 degrees Celsius. Okay? Equal siya sa Gibbs free energy, okay, at 298 Kelvin plus whatever the reaction enthalpy of that process at 298 times 1 over T, okay, which is, this is now your 373 minus 1 over 298. So, basically, ito yung equation. Yung Gibbs-Helmholtz equation. Okay, so, delta G at 373 is the unknown here. Delta G at 298 is given. That's 5.7. Tama ba? Yes. Naka-kilojoules per mole yan. Divided by 298 plus the reaction enthalpy is 35 kilojoules per mole times 1 over 373 minus 1 over 298. Isa lang ang unknown dito, and that's the Gibbs free energy. That's what we are looking for. And lalabas na ang value niya ay minus 1.67 kilojoules per mole. So, if you take a look at the sign of the resulting value for the Gibbs free energy at 373 Kelvin, spontaneous therefore yung ating transformation. Spontaneous and exergonic. So, to answer the question, what will albumin harden at 100 degrees Celsius? Negative si Gibbs free energy, so the answer is a solid yes. Next, let's answer the second question. Okay, ang tanong doon is, at what temperature will albumin start to solidify? So alam natin na nagsusolidify na siya at 100 degrees Celsius according to number 1. Pero ano yung start? Ano yung temperature kung saan nag-start siya mag-solidify? So how do we answer this question? Pag sinabi nating nag-start na siya mag-solidify, point siya kung saan may equilibrium doon sa liquid state at sa solid state. So in other words, the temperature wherein yung albumin will start to solidify, okay, that happens kapag ang delta G natin ay 0. Kasi nga, yan yung point na tinatawag nating equilibrium. Okay, so I'll just rewrite the equation once again. So we have the Gibbs free energy at a certain temperature T. T is what we're looking for. Equals the Gibbs free energy at 298, which is given, right? Over 298. Plus the reaction enthalpy is also given. Times 1 over T minus 1 over 298. Right? But this term here, yung left-hand side ng equation natin is 0. So, 0 yan equals 5.7 divided by 298 plus 35 times 1 over T, we're looking for T, minus 1 over 298. Therefore, T, you can calculate that from this equation, and that will be equal to 356 Kelvin, which is equivalent to 83 degrees Celsius. Ibig sabihin yan, 83 degrees Celsius pa lang yung tubig mo ay pwede nang tumigas yung albumin sa itlog.